Revolutionizing chemistry. Key figures of the early 19th century. The early years of the 19th century saw huge developments in chemistry that fundamentally changed the scientific view of matter. In 1803, John Dalton suggested that each element was made of atoms that are unique to that element, and used the concept of atomic weight to explain how elements always combine with each other in whole number proportions. Jöns Jakob Berzelius studied 2,000 compounds to investigate these proportions. He invented the naming system we use today: H for hydrogen, C for carbon, and so on, and compiled a list of atomic weights for all 40 elements that were then known. He also coined the term organic chemistry for the chemistry of living organisms. The term later came to mean most chemistry involving carbon. In 1809, French chemist Joseph Louis Gay-Lussac explained how gases combine in simple proportions by volume. And 2 years later, the Italian Amedeo Avogadro suggested that equal volumes of gas contain equal numbers of molecules. It was clear that there were strict rules governing the combination of the elements. Atoms and molecules remained essentially theoretical concepts that nobody had seen directly, but they were concepts with growing explanatory power. Valency. Carbon has a valency of 4, making it tetravalent, so a carbon atom can form 4 bonds, as in methane, CH4, where the hydrogen atoms are arranged in a tetrahedron around the carbon. Today, chemists think of a bond as representing a pair of electrons shared between the two atoms, and the symbols H, O, and C as representing the central part of the appropriate atom. Coeur was working at the time at a laboratory in Paris. Meanwhile, in Heidelberg, Germany, August Kekulé had come up with the same idea, announcing in 1857 that carbon has a valency of 4, and early in 1858 that carbon atoms can bond to one another. Publication of Cooper's paper had been delayed, allowing Kekulé to publish a month before him and claim priority for the idea of self-bonding carbon atoms. Kekulé called the bonds between atoms affinities, and explained his ideas in greater detail in his popular textbook of organic chemistry, which first appeared in 1859. Carbon compounds. Figuring out theoretical models based on evidence from chemical reactions, Kekulé declared that tetravalent carbon atoms could link together to form what he called a carbon skeleton, to which other atoms with other valencies, such as hydrogen, oxygen, and chlorine, could bond. Suddenly, organic chemistry began to make sense, and chemists assigned structural formulae to all kinds of molecules. Simple hydrocarbons such as methane, CH4, ethane, C2H6, and propane, CHs, were now seen to be chains of carbon atoms, where the spare valencies were occupied by hydrogen atoms. Reacting such a compound with, say, chlorine, ClZ, produced compounds in which one or more of the hydrogen atoms were replaced by chlorine atoms, making compounds such as chloromethane or chloroethane. Benzene rings. The solution to the puzzle of benzene's structure came to Kekulé in 1865 in a dream. The answer was a ring of carbon atoms, a ring in which all 6 atoms were equal, with a hydrogen atom bonded to each one. This meant that the chlorine in chlorobenzene could be attached anywhere around the ring. Further support for this theory came from substituting hydrogen twice to make dichlorobenzene, CHCl. If benzene is a 6-membered ring with all the carbon atoms equal, there should be 3 distinct forms, or isomers, of this compound. The 2 chlorine atoms could be on adjacent carbon atoms, on carbon atoms separated by 1 other carbon, or at opposite ends of the ring. This turned out to be the case, and the 3 isomers were named ortho, metacomma, and paradichlorobenzene respectively. Establishing symmetry, an unsolved mystery still remained over the observed symmetry of the benzene ring. To satisfy its tetravalency, each carbon atom should have 4 bonds to other atoms. This meant that they all had a spare bond. At first, Kekulé drew alternating single and double bonds around the ring, but when it became apparent that the ring had to be symmetrical, he suggested that the molecule oscillated between the 2 structures. The electron was not discovered until 1896. The idea that bonds form through the sharing of electrons was first proposed by American chemist G.N. Wilson in 1916 In the 1930s, Linus Pauling then used quantum mechanics to explain that the 6 spare electrons in the benzene ring are not localized in double bonds, but are delocalized around the ring and shared equally between the carbon atoms, so that the carbon-carbon bonds are neither single nor double, but 1.5. It would take these new ideas from physics to finally solve the puzzle of the structure of the benzene molecule. Dream of inspiration. Kekule's report of his dream is the most cited personal account of a flash of inspiration in all of science. It seems that he was in a hypnagogic state on the edge of going to sleep, that state where realities and imagination slide into each another. He described it as half-slaf, or half-sleep. In fact, he describes 2 such reveries. The first, probably in 1855, on top of a bus in South London, heading for Clapham Road. Atoms fluttered before my eyes. I had always seen these tiny particles in motion, but I had never succeeded in fathoming the manner of their motion. Today, I saw how frequently 2 smaller ones merged into a pair, how larger ones engulfed 2 smaller ones, still larger ones bonded 3, and even 4 of the small ones. The second occasion was in his study in Ghent in Belgium, possibly inspired by the ancient Ouroboros symbol of a snake biting its own tail. The same thing happened with the benzene ring theory. I turned the chair to face the fireplace and slipped into a languorous state. Atoms fluttered before my eyes. Long rows, frequently linked more densely, everything in motion, winding and turning like snakes. And lo, what was that? One of the snakes grabbed its own tail, and the image rolled mockingly before my eyes. Thank you for joining us on this journey through the transformative world of early 19th century chemistry. We hope you found the stories of these pioneering figures both enlightening and inspiring. If you enjoyed this content, please consider subscribing to our channel for more intriguing insights into the world of science and history. Don't forget to hit the like button and share this video with fellow enthusiasts.